So you like ice sliding block puzzles? Well, you come to the right place, pal. Basically going to be covering all things block puzzles in like a top-down style game. We're going to cover them moving quickly and easily through a grid space, which is a really clean way to design like block puzzles. We'll cover ice sliding mechanics. We'll cover restricting your blocks to a specific little area for puzzles. Like in the video you see here, the little recessed snow, not being able to push a block outside of that area. We'll cover blocks pressing switches and how you can code things like switches to do simple things like opening doors for you, which is pretty integral to block puzzles. And we'll cover how to reset a puzzle like this, so that way the player doesn't get themselves stuck. Easy. This is an add-on of sorts to my How to Make an RPG series on my channel here. You don't have to watch the whole series. I am going to start my file with my own player character from that series, but any kind of player character you already have should work totally fine. I tell you what things you need to add to your player and how to find those things. Like, for example, use a variable called face. That's important to get the direction that we're pushing blocks in. I show you how to get that with any character, but if you want to make a character just like mine, you just have to watch part 1 and 2 of the RPG video, and those videos are for super beginners, so you should be able to blow past it pretty fast if you're already looking into stuff like block pushing mechanics. So regardless, you're going to be fine if you watch it or not, but if you find yourself getting a little lost, go ahead and watch it. Anyways, if you want this full project file and all of the assets that you see in this video, then I offer that on my Patreon, so you can check that out. And Patreon members also get these videos early, so that's another perk for you. Check that out if you want. At some point, I will release a game called Starcross Starcade Special. A trailer's here on my channel, and there's a link to wishlist it in the description if you want to do that. So anyways, now that I've done all my housekeeping and self-promotion, let's make a game, baby. Okay, so as I said in the intro, I am not starting from nothing in this video, but basically just because I need a character. Let me go over what I have really quick and I'll tell you exactly what you need. So hopefully you'll be fine if you have your own character. You'll definitely be fine if you have the same character from the RPG series and you actually watched those and you did those. But regardless, it should be easy. So let's just go over that really quick. So first of all, my player is a 4-directional player sprite. It's got a down, right, left, and up sprite. You know, all their origins match up and everything. Again, if you don't have a functioning character at all and you don't know how to make one at all, then start with just do the first couple episodes of that RPG video. But so I got my player object. We'll go over that in a second. I got a wall, just a simple wall sprite, a 16 by 16 square, and then an object wall with absolutely no code in it. So that's all that is. Then I have the script here that called script macros. And it's very simply, I just set up a couple macros. And macros are basically just you're defining your own constants in GameMaker. So they're kind of like global variables where you can reference them anywhere in the game that you want to, except unlike global variables, you can't change their values. They are a constant value. So this is how you set them. So for example, I got my macro, right. I used all caps for it because I actually picked this up from Heartbeast a long time ago, who I think mostly does stuff in Godot now, but had a really good series years ago for GameMaker Studio 1 that I watched when I was learning. And I've set up this macro as all caps right to be 0. Then I've set up a macro of up to be 1, left to be 2, down to be 3. And these directions are basically corresponding to 90-degree divisions of a 360-degree circle, as you can see on this graph here. So 0 times 90 degrees is 0 degrees, which is to the right. 1 times 90 is going to be 90 degrees, which is straight up. 2 times 90 is 180, which is left. And 3 times 90 is 270, which is straight down. And that's how we're going to be determining the direction or the facing direction of our character. And that's what's going to be important because that's how we're going to push blocks. We need to know which way the character is facing. So cool. Let's talk about my character really quick. So opening this up, I have a lot of things. I have this array which controls my the way my sprites look, but the important thing is this variable here, face. So by default, our face is set to down, which is, you know, this one, and our face will always be right, up, left, or down. So again, if you want to copy this exact character, go to the RPG series, but if you just want to understand the face variable, then I'm going to go through that real quick. So when it comes to my moving, I'm using the variables X speed and Y speed. Again, I just set these myself. You may have like, you know, X speed and Y speed like that, or you might have H speed and V speed for horizontal speed and vertical speed. It doesn't matter. Here in my step event, you can see I'm getting my inputs, and then I have my movement code here. I get my X and my Y speed right here. I set the correct face variable in this section here, and then I use that to control my sprite. But again, the face variable is going to be very important. So I control my sprite, get the face variable, then I collide with walls, and then I actually move. So chances are, even if your character is a bit different than mine and you use someone else's tutorial to make a character or something like that, chances are you have something really similar to at least this part and these parts, which is just, you know, adding an X speed and a Y speed to your X and Y variables. That's how you make characters move. So if you have a character, you have that. And so this section right here where I'm calculating the face, you can basically just use this bit of code if you don't have it. Now, obviously, you're going to have to swap in the correct variable names, but and of course, however you're getting your collision mask, you've figured that out for yourself, and however you're doing your sprite index, you're figuring that out yourself as well. So really, it's just this part that's important, so you can get this variable to be correct. I calculated it just based on how we're moving left and right and up and down, so you should be able to do that too. Easy. It's basically saying if we're not moving up and down, and if our x speed is greater than 0, if we're moving to the right, then we're facing the right. If we're moving to the left, then we're facing the left. And then we have a couple lines that are mostly just for fixing some like diagonal movement issues. So it's basically saying if we're moving to the right, but for some reason our character is already facing to the left, then just force the character to face the right. And if we're moving to the left, for some reason the character is already facing the right, force them to face the left. And then we do pretty much just the opposite thing over here, where we're saying if we're not moving left and right, then we're either moving up and down, and then a couple fixie lines of code too. So basically, you're just making sure that your face variable is tracking properly if you're moving left and right or up and down, and that's the way that your character is actually facing. So that's really the important thing. Now, you probably have your own collisions, and if not, this is how you do them. It's very simple. You just check if there's something in the way of your X speed. If there is, set it to 0. Then you check if there's something in the way of your Y speed. Then you set that to 0. And then you actually move your character. And the last thing I'll mention is just the depth code here. I'm using the depth equals -y method, which is a really common and simple method, and that just helps with the faux 3D kind of look that a lot of top-down games have. So remember, the important thing is getting the face variable. Get all this back together, then I'm going to minimize this. And before we'll start, I'll just let you test it really quick. Here's a good way to test it. You could add a draw event to your character if you don't already have one. Make sure that you draw your character. That's important. And then you could just do something like draw text, and we'll draw it at the top left corner of the room. So we'll say at the coordinate 16, 16, and then we'll tell it to draw the string of our face variable. This is just going to make sure that your face variable is being correctly set. So go into whatever room you have. I think for doing this, just go ahead and make yourself a blank room that is the size of your camera. If you don't have one, here's what I'm using right now. My room is 320 pixels wide, 180 pixels tall, and then I enabled my viewports so we can actually see the game. And in my viewport 0, which is the default one, I made sure it was visible. The camera itself is also 320 pixels wide and 180 pixels tall. And then for my viewport, I did 960 by 540, which is just half of 1080p. So half of a 1080p monitor. Again, chances are you have all this stuff done anyways. So I'm gonna drop in my player really quick, and might as well drop in some walls and stuff too. Go ahead and make sure that your player is working the way you think it should be working, that it's running into your walls, all that stuff. We don't want to have any problems once we get to the actual pushing blocks. And yeah, I'm gonna run the game really quick. Okay, so it says my face variable is 3, which 3 is the down variable. We can highlight our macros here on the left and you can see it. So 3 is down. If I go to the left, that's 2, that's matching. If I go up, that's 1, that's matching. And right, that's matching. And then I have my sprite control to kind of, follow properly and have like a proper hierarchy. But the point is just if you press right and let go, it should be 0. Press up and let go, it should be 1. Left is 2, down is 3, or whatever your macro values are, because if you had 8 directions, then the numbers might be different, but just make sure that they're matching your macros. So right, up, left, down. Good. And if you're doing this in a bigger, remember, we're only drawing this at 1616 pixels, so you have to go to the top left of your room to actually see this. Otherwise, it'll go away. But so the face is working, and then make sure that your player is working that the way they always have. They're running into walls and they're stopping. There's no issues with their collision masks or anything like that, and everything is good. Now, if everything is good, then we're ready to actually get started on our block pushing stuff. Okay, so I'm going to close this and I'm going to get rid of that draw event for my player just because I don't need that. Okay, great. So to sum up, we have a working player, we have working walls, we have our macros set up, our face variable works, and we have a room and camera set up so we can at least just stand in a room and test our game. Sounds great. Okay, so yay, time to really get started. Here we go. First, we're going to want a sprite for our push block. So I'm going to create a sprite. I'm going to call it S push block. And let's edit it. And if you are coming from the RPG series, obviously you'll notice that I have changed in my naming conventions since then. So the way I name objects and variables is going to be a little bit different. So sorry about that, but it's just kind of a dirty transition we're going to have to make. So here's what I'm going to do. It's going to be at its base like a 16 by 16 block, but I want it to have a little bit of height. It's going to be like a block or a crate or something like that, right? So I'm going to change my grid settings. I'm going to change the grid wide to 8 because I want to make it 8 tall. So it's going to be like this, and then I'm just gonna fill it in with some colors. So maybe like purple, and then maybe we're gonna do like a little bit darker purple down the side because it looks shaded, right? So there we go. Got a nice looking box. I'm gonna go to image and auto trim, get rid of all the excess stuff. And then here's how we're gonna set up the collision mask. Easy peasy stuff. If you do like boxes and crates like this and even like barrels or whatever, the easiest way to set these collision masks up, like most accurately, I would say, would be to go into collision mask, set it to manual, and then draw your square or rectangle to fit the very top of your object and then scoot it down to its base. So you can see this will be the part that the player would run into, and here's where the player would be able to walk behind it. So cool. And then I just personally like my origin to match up with the top left of this. So I'm just gonna, I could drag it down, but I also just know that it's just 8 pixels down because it's 8 pixels tall. So there's my origin now. If I check here, it's to the top left of this. So that way I can set it in our 16 by 16 grid properly in the room. So definitely do this. So definitely make your life a lot easier. So cool. The sprite's done. And now that means we can actually work on the push block itself. So let's right click, create an object. It's gonna be push block. Great. We're gonna select our sprite, and there it is. So these are blocks, pieces of the environment. First things first, we're gonna have our object wall be the parent. So go to the parent tab, do the drop down, select your wall object. And so now the player should be able to run into this easily. You won't need any other code or anything like that. So easy. Let's set up our create event first. So add event, create, and this thing is gonna be moving at some point. And I probably mentioned it in the intro, or at least you saw it in the footage, but the cleanest and easiest way to do this simply is to do it where our block moves in automatic grid spaces. That solves a lot of problems for us immediately, having it be able to move just 16 pixels at a time or whatever your grid size is. One, it makes sure that the player never has to awkwardly perfectly line up the blocks in your game whenever they maybe have to like push a block down a single tile high little path or something like that. And it also means that we don't have to create like a pushing state for the player where the player like slows down and changes to pushing sprites, because that's a lot of work and that's a lot of stuff to add, and there can be a lot of problems with that. So this is how we're going to do it. So first, let's set up some variables for moving. So like anything else that moves, we're going to use an X speed variable and a Y speed variable, right? It's got to move left and right, and it's got to move up and down. This is how I make everything move in these top-down games. And then we need a variable to control how fast it actually moves, and that's going to be our move speed. Now go ahead and set this to whatever you want. I would recommend the one criteria being it is either the same speed or faster than the speed your player moves at. So my speed for my player is 2 pixels per frame. So I'm going to set my block to that. I could set it higher if I wanted to. And in fact, you know what? I might as well just go ahead and set it to 3 because I want to show you guys something in the way that we handle our movement here. Remember, these blocks are going to need to move a single grid space at a time. That's just the best way to handle this while being the simplest way to handle it without introducing a lot of different things that we would have to compensate for, like different player states, or making sure that when we design levels, we don't design places that are too tight for the push block. So it'd be really hard for a player to precisely angle something between two other walls or objects or something like that. So if we keep everything to the grid space, one, it works really fast. It's not cumbersome at all, which is great. And two, it just cuts out a lot of extra work we'd have to be doing. So we're sticking to the grid spaces, and for our grid, it's going to be 16 by 16 pixels, right? That's how most of these games work. So we want to make sure whenever we're moving to our next grid space, wherever that is, we're not overshooting it or undershooting it. We're arriving exactly where we need to. So if our grid space is going to be 16 pixels wide, for example, and say we're moving to the right, so we're trying to add 16 pixels to our direction, 3 doesn't divide into that evenly. You'll have 2 stray pixels there because you'll get up to 15 pixels over 5 frames, and then you'll overshoot 16 and you'll get to 18 pixels instead. So we're going to build in a way to control that and contain that, and that way you can set your move speed to anything you want. You could even set it to something really stupid like this, and it should totally work out fine. Wouldn't recommend doing sub-pixel stuff for something like this just because it doesn't really seem necessary, but I will pick a weird number like 3 that doesn't fit into 16 evenly, so we can see how that works. So that's great. And then lastly, the direction that we need to move in, and that's where the face stuff comes in, right? So we could call this face, or just to remember it properly, we could call it face dir. It doesn't matter. It's going to be the same thing. This will be using our right, up, left, and down directions. So 0, 1, 2, and 3. We're just going to use our macros to name them something nice and easy to remember. But for now, this value doesn't matter because our player is going to be controlling it with their face variable. So when the player tells the block to be pushed, the block is going to inherit the direction that the player is facing, right? So at our create event, it doesn't really matter. I could set this to left, up, down. I could even set this to like -90 or something. It doesn't matter at creation. So cool. We have all that. Those are the actual variables that we're going to need to move, because this is going to be our left and right, our up and down, the speed that we move, and the direction that we move. So all that's nice and good. Next, we need to set up another group of variables, and this is basically how far we're going to need to move. So there we go. And this kind of goes in with what I was talking about like the grid spaces and stuff like that. So for example, our first variable is going to be grid space. So the size of a unit of our grid, which is 16 pixels, right? Like if I open up my room, this is a 16 by 16, 16 by 16. These are all 16 by 16 pixels. So we're going to lock into a grid of this size. So that's cool. We need that information, and we already talked about that. So then we basically need 2 coordinates. Whenever we initiate the block to start moving and sliding, we need to know where we started, and we need to know where we're going. And we're going to need, both of those coordinates to update every time we want to move. So for example, if I have a push block here and it's in the room, and you can see down here, it's at 32, 32, the coordinates. So it's right there. And if I move it over, it's at 48, 32. So let's say we're starting at 48, 32. Anytime we need to move, we want to know where we started. So we're going to say 48, 32, and say if we're moving to the right, we know that we're going to want to move to the right 16 pixels by using this variable. And so what we need to know is where we want to end up, which is going to be our starting X position, which is that 48 plus that 16. So then we're going to get the 64. So that's why we need to know both of them. We need to know the start one, so we can add the new amount of space we need to go to it to find our final destination. And then we need that final destination so we don't, so we know not to overshoot it, just like I was saying when we were talking about our movement speeds. So I'm going to get rid of that. So here's how we're going to name these. We're going to say this is going to be start point X, and that can just be our X. Start point Y can be our Y. Then we'll have target X, that can just be our X, and target Y, which can just be our Y coordinate already at creation. Cool. Now I chose this name very specifically because there are built-in variables for objects called X start and Y start. Now these are different, and we're actually going to be using these at some point, and I'll explain a little bit later. But again, we're going to be updating our start point X and start point Y every single time we need to move, where X start and Y start are the X and Y coordinates of whenever this block was first created. So basically, wherever we put this block in the room, no matter where we move it, X start and Y start will always be those original coordinates. So if we wanted to add in a mechanic, for example, to reset puzzles, which is very useful for push blocks, especially because depending on how you design your levels, you can get them stuck easily against walls or something like that. Having something like X start and Y start is very useful, and we are going to actually be using that. So these are not useful at the moment, but they will be. So that's why we have start point X and start point Y, and then target X and target Y. Cool. So we have everything we need to move, and we have everything to know where we need to move. Great. So let's go to our step event now. The last thing we want to have is just what state are we in? Now, normally I would make like a state machine, and I would make a variable called state and like set it to 0 and have multiple things and do a switch statement, all that kind of stuff. If you don't know what I'm talking about, don't worry, because this is just not going to be complicated enough to need that. We really only need to know whether or not this thing is moving, like it's been pushed already, or it hasn't been pushed. So we can just have a variable called like sliding. So we either are not sliding or we are sliding, or you can call this moving if you want to. It doesn't matter. I would suggest calling it the same thing as me just so you don't get confused, but yeah, that's really all we need to know. I think you're not adding state machines on top of all this other stuff we're going to talk about is probably a good idea. So this is our create event, and it's all ready to go. So now we can talk about our step event. So let's just start off by breaking this up into those two different states, right? So what state are we in? And I'm going to start with idle / not sliding. So if sliding is equal to false, then we can run some code. And pretty much any time that we're not sliding, this is a great time to set our starting coordinates, right? So set our start point X and start point Y. So we can just do this right here. Anytime we're not moving, we're in our grid space where we need to be. And so once we start moving, we can use this as a reference point, right? Because we're only setting it when we're not moving. Easy peasy. And likewise, when we're not moving, we're not moving. I know this is a bonkers concept we're working with here. But yeah, let's just go ahead and set our X speed and our Y speed to 0 to make sure that we don't move at all whenever we're not supposed to be, whenever we're not in the sliding state. So cool. That's all we need to do here right now. And now we can work on our actual sliding state. So if sliding is equal to true, then this is when we can actually do our moving. So here's where we get to the good stuff. First thing we want to do is get the actual 360-degree direction we should move in. So like I said, our player is basically going to tell our push block to move and slide, and it's going to tell it what direction it's supposed to do it in. So by the time we're in our sliding state, we have updated our face dir variable to be right, up, left, or down. So let's make a local variable. I'm going to call this var real dir for real direction. That's going to equal our face direction times 90 degrees. Right? Talked about it in the beginning, but you know, 0 times 90 is 0. Straight up is 1 times 90, 90 degrees. Straight left is 2 times 90, 180. And straight down, 3 times 90, 270. So we need this actual 360-degree direction. You know what? Let me just type in degree right there. 360-degree direction. We need that to actually use some functions to calculate like the speed at which we're moving at. So that's the first thing that we needed to get. And we're going to be using that right now whenever we get our target coordinates. So we figure out exactly where we're trying to go. So let's just do our target X first. We're going to be doing both, but let's just talk about it this way first. So we're going to be taking our starting coordinate, and then we're going to be adding a value to it to change it. You know, like I said, we figure out we're moving right, so we need to add 16 pixels to where our start point X was. That will be our target goal. So first, let's find the value that we want to add. So I'm going to call this target X dist. So target X distance, the distance from our starting point that we want to go. And let's use this cool function called length dir x. And what length dir x and length dir y do is a really cool thing. I've covered it in videos before. I covered it in my top-down shooter series pretty extensively because it was very important in that game. But these are really important functions in general. They're really cool. Essentially what they take is, down here you see, they take a len and a dir. So they take a length and a direction. And you can see here on the screen, basically you're giving it the direction on a 360-degree circle, and then you're giving it a length to shoot out from the origin of the circle to the edge of that circle at, you know, whatever degree you choose. And then length dir x is figuring out how far that x position is from the origin, and length dir y is figuring out how far the y is from the origin. And basically you can use these two to get like realistic 360-degree directional movement for stuff, instead of just like a digital type movement like I have with the, you know, this particular character in this project. In our case, this will give us exactly how many pixels we need to go to get 16 pixels away in whatever direction that we're choosing. Now, for us, you know, our real direction is always going to be either 0, 90, 180, or 270. So we're not really using that full 360-degree movement, but we are using it to simplify our code a lot. So for example, if we're facing the left, face dir, that will be 2 times 90 is 180, which is leftwards on a circle graph in GameMaker. So if we're going our grid space distance, the size of our grid, which is the 16 pixels, and we're going towards that real direction, which in this case would be, you know, 180 if we're going to the left, then length dir x is actually going to return negative 16, because that's how far the x coordinate of 16 pixels directly to the left of 0 is, right? So that should make sense. And say, for instance, if we're going straight up, so face dir is 1, we're doing 90 degrees, we're going straight up. The difference between the coordinate 16 pixels above the origin and the origin, the x isn't actually different at all. So that's just 0 pixels. It's the y that is negative 16 now. So now you can see that no matter what direction we're in, we're getting the correct offset that we need to go to. So then to set our, you know, our target x like this, we would say our target x equals our start point x, and then we're just going to add the target x distance. And then we're golden, because again, even if, you know, this is either going to be positive, or it's going to be negative, or it's going to be 0. So it's basically taking care of itself all at once. So we can also do this with the y, and it's going to be the same thing pretty much. So you see, that's exactly what I've done here. Be careful. Don't just copy and paste, retype everything properly, because this needs to be called target y distance. And then you need to use length dir y, obviously. And then down here, you need to set your target y to be the start point y plus the target y distance. Oops, all Ys, no X's. Okay, so cool. We have our coordinates that we need to go to, no matter which way our direction is. So now we need to set the speeds, and this is gonna be cool. So I'm gonna give myself a little bit more room, not be so crunched up here, and I'm gonna get rid of this too. So I was talking about how the movement speed is really important and how it not dividing into 16 evenly could cause problems and stuff like that. Well, we're gonna solve that problem as we're calculating our X and Y speeds, and that in turn is gonna help us do other stuff too. So first, in solving our little problem, we're gonna make a local variable and we're gonna call it just target dist. So this is gonna be our distance to our target X. So let's use this function called point distance, and we can put in 2 coordinates and it'll give us the exact pixel difference that we have between the 2 points. So if we use our current X and Y position with our target positions, you know, where we're trying to go, then this is going to return that exact distance. And this is going to be helpful because we need to know if this distance is actually, you know, for some reason, if it's less than our movement speed, because we don't want to move our full movement speed if this, you know, if we're only a single pixel away from our target X and Y as we're moving through each frame, then we don't want to move 3 pixels towards it. We only want to move 1 pixel towards it. So here's how we can do that. Instead of immediately doing our X and Y speeds based on our movement speed, we can do a local variable and we can call this final speed. Basically, we'll choose between these 2 variables, our movement speed and target distance, by doing this. We can pick whichever one is smaller, right? So we'll either move our movement speed or we'll move our target distance. For the most part, our target distance is going to be way above our movement speed because we start at, you know, a 16 distance and our movement speed in our case is only 3. That's what I set for mine. So most of the time we're only going to be moving our movement speed, but then once this goes under 3, then we're just going to move that exact amount. So it gets us the exact pixel coordinate that we want to go super easily. So now we just need to calculate our X and Y speeds based off of our final speed here. And cool enough, we can just use our lengthdir operation again, right? Because we have a length that we want to move in. That's our final speed, you know, that's the length that we want to move. And the direction that we want to move is just our real direction, because that's the 360-degree direction that we have based off of our face, all that stuff. It's really easy. If we want to move to the left, we are going to move 3 pixels a frame towards 180 degrees, which is left, until we need to move less than 3 pixels, and then we're going to move less. We're just going to move the perfect amount at that point. So that's how you do that. So as you see, I've done the same for my Y speed. I've just made sure that I'm using Y speed and I'm using lengthdir Y, and same information here. So great. And then normally in these kind of situations, what we would do is we would add in our collisions right now, right? Now we could do this the traditional way, which, you know, like I did with my player, which is using place meeting our X plus our X speed and our Y position, and if there's a wall in the way, then, you know, set our X speed to 0 and don't move anymore. However, since these block puzzles are very grid based and we don't want to have the player like get the blocks out of sync or anything like that, which could cause really big problems, an actually easier way to do that, which will guarantee that your block stays in its grid path, is to sort of do it like this. We'll say, don't let the block move to a grid space that has a wall in it. And so instead of having to do the 2 separate checks for X speed and Y speed and, you know, worrying about if the collision is like precise and all that stuff, we're just going to check the whole space, because we don't want our block to get like halfway through a space and then stop, because then it's going to be offset from the grid. So we can just say if place meeting our target X and our target Y with our wall, then we can just set both the X and Y speed to 0. Easy. Oh, why is that so far back? There we go. Yeah, easy. Now this may not be exactly what you want. There's a ton of ways to handle this sort of thing. You know, at the beginning of the game, we could like establish a grid, like where the blocks are supposed to be, or you could, you know, use the blocks starting X and Y coordinate to figure out where the grid should be. And so you could have them halfway move onto a grid and then make sure they snap back to the right place. That's just a whole lot of extra stuff. And the point is you probably in these puzzle scenarios, you're probably not going to be placing random walls that are, you know, taking up irregular space, right? Because design-wise, that would just be a little messy. It'd be tough for a player to know how to solve a puzzle or how you want them to go about it if you have random walls not locked into your grid in these kind of environments, right? So this should be totally fine. This should work completely okay. So as always, now that we've calculated the X and Y speed, and we're done with all of our state-specific stuff, so we have our not sliding and our sliding state, we can just get to move the little block guy. So X plus our X speed and Y plus our Y speed. And then after we moved, we can just check if we're done with sliding. So we can say done with sliding, and that would be in the case that our X speed and Y speed aren't moving anymore, right? So if our X speed is equal to 0 and our Y speed is equal to 0, then we're not sliding anymore. So we can say sliding equals false. And actually, you know, I actually suppose this little check here could probably actually just go into the sliding state over here. So if you want to, you can move it right over here. Won't probably have a huge impact either way. I think it would technically be better to put it in here, but you know, for now we'll leave it here. I have it here in my outline project, so I'm not going to stray too far from that, but that should work totally fine. And yeah, that's pretty much it. And then if we just want to do one more little thing just for the polish, we can set our depth, and I'm just going to say the depth equals the negative bounding box bottom. It could be negative Y, negative bounding box top. It probably wouldn't really matter regardless, but you know, I just chose the bottom of the collision mask because nothing's really going to show up on top of it regardless, so whatever. So that should be good. The main way we're going to be testing this is by our player pushing it, but for now we can just add in like a really crude test. So slide in random direction test, not text. Crazy man. So I'm just going to say if keyboard check pressed VK space. So I'm gonna use the space button here. Basically, I'll set the face dir to be, I could just use iRandom, but you know, just to visualize it, I'll tell it to choose either right, up, left, or down. So it'll pick one of those four, any random four, and then we'll tell it to slide. So we can say sliding equals true. And basically, if we put our block in the room, I'm gonna get rid of these walls at first. We will be able to test the wall collision for this push block, but we'll do that with the player. So we won't do it with like, you know, random stuff. So again, make sure that, you know, everything in here is correct. Make sure you've copied all this correctly. And you should be good. Remember, make sure that your X speeds and Y speeds are all appropriately matched with X and Y functions and all that stuff. So let's check and also hope that I didn't mess it up. So if I press space, okay, look at that. So it randomly moved to the right, then left, up. Yeah, look at that. So this is how it's, you know, gonna move around. All right, cool. There it goes. Bye-bye. Yeah, so it looks like it's working. So if that's kind of the behavior that it gets whenever you keep mashing the button there, then that means that it's probably working exactly how it's supposed to. And that means we can move on to how our player is actually going to interact with it. So I'm going to go into my player, into my create event, and I will reiterate just one more time that the only thing that's important is that your face value is working properly, like how I showed you in the beginning, where, you know, if you press right, it's returning 0, press up 1, left 2, down 3, right? That's the only thing that matters. Your player can be totally different every other way, as long as it runs into walls and the face variable is working. So I'm gonna add a new little thing, and I'm gonna call this for interaction. And we want a variable to say how close do we have to be to an object to interact with it. So I'm gonna say our interact dist for interact distance is just gonna be like 4 pixels. So it basically just has to be 4 pixels in front of the player, and that's it. My one note about this is since, for example, my player does not have any kind of precise colliding. You know, my player has very simple collision. So for example, if my player's move speed was like, you know, a high number like 5, and say if I was moving to the right and so X plus 5, I was running into a wall, it would just stop my player. It wouldn't scoop me up to the wall. So theoretically there could be 4 pixels of space between me and the wall, and I can't move any closer because anytime I try to move closer, it'll be checking 5 pixels ahead and then it'll set it back to 0. So yeah, I'll talk about precise collisions one day. It's a pretty simple thing. It's pretty cool stuff. I've actually done a video for GameMaker on their channel for a platformer type game, so you could check that out. I think it's just called platformer movement and collision or something like that. But basically my point is that's okay. That's totally fine to have that. But like I said, if I was 4 pixels away, then I would be too far away and I couldn't get any closer. So make sure that your interacting distance is higher than your movement speed. So my movement speed is 2, so interacting distance of 4 is perfect. That's totally enough. So now I can move on to the step event. And I don't need any of this old code. Like I said, this is all going to be independent. Just as long as I have my face variable, I'm fine. So I'm going to add a new key input, and this is going to be my interact key, and I'm going to call this interact key pressed because I'm going to be using keyboard check pressed, not just keyboard check. And we're going to use the space key. That's going to be our interaction key for this this little thing. So I can even go into my push block and I can get rid of this. I don't need this testing anymore. So I can just completely get rid of it, and you should too, because that will mess with things. So don't forget that. I'll try and remind you again if I remember to. But yeah, so now we're just going to interact with the push blocks. And this code is going to look really familiar because we're going to use a lot of stuff that we've already used. So first, we're just going to check if the interact key pressed has happened, right? So if that's true, if our space button's been pressed, now we need to check for a push block. And so we're going to be checking the direction that we're facing. So let's do the same thing we did last time. Find the 360-degree direction to check for push blocks. I'm going to call this var underscore checkter, or again, you call it var realder like we did last time. And that's going to be our face variable times 90 degrees. Again, it's the same thing. Using, the variable names are slightly different and the local variable names are slightly different, but that's just because I feel like they make more sense in each scenario. So anyways, so the direction we're checking is going to be our face times 90, exactly like how the push block stuff was checking when it was sliding. So let's go back over into our player. And now let's say, see if we find a push block. So let's find our coordinates that we're going to be checking at. We're basically just going to be checking in the direction that we're facing, obviously. And we're going to check pushed outwards with our, interact distance. So we're going to check 4 pixels ahead of us, whichever way we're facing. So local variable, our check X, that's going to be our current X position plus our length direction, and that's going to be the length of our interact distance and the direction of our checking direction, right? So it's basically just going to be pushing our collision mask forward 4 pixels in whichever 360-degree direction that we're facing. And we have to do that for both our X and Y, so do the check Y, just like this. Remember, call this check Y, checking our current Y position plus the length direction Y of this information. Same thing. So cool. And then we're going to use a very, very similar function to place meeting. We use place meeting to check for stuff. We use it to check for walls when we run into them. And so we're going to use a very similar function to check for our push block. But we are going to use a function called instance place, which basically does the same exact thing, except if it does run into the thing you're looking for. So we're going to be checking for a push block. If we do run into a push block and it tells us that there is one in that space, it won't just return true or false. It'll actually return the instance ID of that specific block. So it'll basically mean that we can retrieve exactly which block we're touching, not just the fact that we're touching one. And that means that we can tell that specific block to start moving if we're pressing our button like we are. And so because it's returning that ID, we can go ahead and store it in a local variable. So I'm going to call this push block inst for push block instance. And we can set that equal to our instance place function. Like I said, it works just like place meeting. So we're checking an X and Y coordinate and we're just checking for a certain type of object. So we already know where we want to check. That's our check X and Y. That's what we just did. And then we're checking for a object push block. So cool. So we're checking if we've found one. And if we do find one, we're returning, the instance ID. If there's not one in that place, then instance place just returns the keyword no one, which is basically just, the value is -4, but basically it just means that no, we didn't return anything. And so, push block instance will be the value no one. So now we can check if there is a push block, then we can tell it to slide and which direction to slide, right? Easy stuff. So first let's check if we have one, and we can just use instance exists for that. So we could say if the instance exists, our push block instance, oops, there we go. So again, if this is set to no one, if we didn't find one, then it'll just say like, no, it doesn't exist. So yeah, if the instance exists, we can tell it to do something, but we also don't want to tell it to start sliding if it is already sliding around, that's one of those things where it would probably be a very unlikely scenario a player would like be double tapping this button. And even if they did, it wouldn't change anything, but there may be a scenario where the player is like on the top corner and it tells it to go to the left, and then the player moves up and faces down and tells it to go downwards, like a frame later, somehow does some frame perfect thing. It'd be very unlikely with the way that we've set the speeds of the push blocks to work, but again, it's possible. So first, we're checking if it exists, and then we want to say, if it does exist, then we'll say if our push block instance dot sliding is equal to false. So if it's not sliding already, if it's not in the sliding state. And by the way, we can check this in this order like this without having to put another check inside these curly brackets, because GameMaker is optimized in a way where if push block instance doesn't exist, if this is already made false and we're looking for an and after that, GameMaker already knows that it doesn't matter what this is, because this is false. So both already aren't true. So GameMaker won't even read this part of the code basically. So We won't get a crash here because, you know, we're not looking for an object that doesn't exist. We've already checked if it existed here. Then we're checking if it's not sliding. So if it exists, and then if it's not sliding, we can tell it to slide. So we'll put the push block instance dot sliding to be true. So it's in the sliding state. And then we can tell its face direction to be our face variable, the player's face. Because the way that we're checking for it, this will make sure, you know, there should never be an instance where you stand to the right of a box and then face yourself downwards, then press interact, and then the box to your left goes down for some reason. You know, it shouldn't work out to do that. So basically the block is just inheriting the way that the player is already facing. So that should work. You know, this should do it. So let's just make sure that's true. Before we test, go back into your push block, make sure you got rid of the testing stuff at the top of the step event we did where you press the space bar, because we don't need that anymore and it will mess with everything that we're doing. It will really mess with everything we're doing. So make sure that's fine. Go ahead and make sure that the push block is parented to, you know, the object wall. So that way we can run into it and stuff. And yeah, I'm gonna go back in my room, and before we test, I'm just gonna go ahead and add in a couple walls so we can make sure that this won't, you know, run into it or overlap. So since everything is on the 16 by 16 grid, it shouldn't give us too much of an issue. So let's test it out real quick. Okay, so here we go. So first of all, and I didn't test this last time, I could have, but the player shows up behind it and in front of it fine, and the player can't move into it because it's a wall. And if I press space, oh, look at that, look at that. We're moving it. We can move it any direction. We can move it while we're holding the button if we want to. We can just press it. Great. And does it move into the walls? Nope. It's not moving into that one. What about from the left? Nope. It's not moving into it. Nope. And from down? Nope. All right. And if we want to, we could add in, you know, a couple more of these. And I mean, they're all walls, so they'll work fine. But, you know, we can just test and make sure that they won't run into each other. So I can't move that one to the left. Can't move that one to the right. I can scoot that down, scoot that down. Can't move this on top of it, but I did move that one for a second. The size of your player's collision mask will, you know, affect how easily it selects one of these for you. So for example, like if I have these two right next to each other and I stand right in the middle, because we're using our instance place thing, it's just gonna kind of pick a random one for me. So if I hit the space bar, I don't know if it's gonna be the top or the bottom one that's gonna move. So, okay, yeah, so it was the bottom one, but now if I press it, it'll be the top one. That's just kind of how instance place works. So if you want to do a block pushing puzzle and you have a really big character or something like that, or a character that's about the same grid size, and like the block pushing puzzles need to be really precise, and you want to make sure that the player never is like, oh, I want to move this bottom one. See, I'm like kind of closer to it, but maybe the top one goes first. Well, didn't on that one, but you know, you get the idea. Then you might want to make your blocks a little bit bigger, and you might want to make the grid for the blocks bigger. But the way we set that up, it's easy. You would just have to make a bigger block sprite and make sure it's, you know, sprite index matched totally fine. And then you would just need to set your grid space to the size it needs to be. So if you wanted to make it twice as big, it would just be 32. So that's how that works. And yeah, that's the very basics of block pushing, but we are not done, kiddo. Sport. Reason number one. Okay, so I'm gonna do this right now, and oh, look at that. Oops. Now now I can never get this block away from this wall, and if I push it one further, now I can never move this block ever again because I'm stupid. Yeah, so having a way to reset these kind of puzzles is important. Really, what you want to do is design your game probably to where this kind of situation doesn't really happen easily. But so you want one thing. You want a way to reset your puzzles and stuff like that. That can be done very easily. I'm going to show you that. And we also want to do more fun things with block pushing, right? Because just pushing a block by itself, it doesn't really do anything. I can't really think of a way to really make a puzzle out of that unless it was like a Link to the Past type puzzle where there's like 50 of them squashed together and you just have to figure out where you can even push any of them. What comes to my mind with these kind of puzzles is ice sliding puzzles. Yeah, I mean, you know that because I probably titled the video something like that and also probably said it in the intro. Haha. But some people hate these puzzles. I frankly hate those people. I really like ice pushing puzzles. Just kidding. I don't hate you if you hate those kind of puzzles. I get it. They're in a lot of games, all right? And sometimes they're really hard. But I like them all right. And it's a fun kind of puzzle to make too. So I figure that's just something a lot of people want to know how to do that. So we want to have this system work with like ice. I also want to give you a tool to help avoid scenarios like this with having specific zones where you can like push blocks, right? Like as you saw in the intro, in the snow part, there was like an indented part of the snow. And whenever blocks were in that indent, they couldn't get out of it. And that basically means that they have, edges to the puzzle, but they're not up against solid walls. So the player can still get back around and push them back into the middle and stuff like that. So you don't have to reset a puzzle every single time you're trying to solve it, right? And both of those are two very, very common things in games. The sliding block puzzle and like having patches of dirt or something like that, where it's just like, this is the puzzle area, this is where the puzzles sit. So we're actually going to start with both of those, and then we'll talk about resetting at the end, because resetting is very, very easy and it'll just take us like 2 seconds. So I'm going to clear everything out of here. Now we're ready to start working on that. So I'm going to make a new sprite, and I'm going to call this S push block area. So this is just going to be like, the little indented area, the little dirt patch, specifically our push block puzzle place, And I'm going to make this like a yellow color, pale color, 16 by 16, low opacity, auto trim, and we've got the sprite ready. Now I'm going to create the object. So I'm going to create O push block area and set the sprite. And cool, this is just literally going to be a defining area for where we can do these things. So it doesn't require any code. It's just like the wall object. It's going to be our push block that's actually figuring out stuff based on this. Now we're not going to use this as a wall, actually. We're going to use this to specifically draw the play area. Really quick, I'm going to load in my, I'm going to get in my tiles that I made for this project, and I'll show you what I mean just for a second. Okay, so here's sort of what I'm talking about. You can tell that this is just a defined area to do the push block puzzles in. By the way, if you want to look at the tile set really quick, here it is. Here it is for you. It's regular snow, some ice for the sliding, and a little indent and like pathway stuff, and then just some weird little bushes. Feel free to pause and copy this, or you could also just get this whole tile set along with all the other assets to this video on my Patreon, as I mentioned. So yeah, feel free to do that. But anyway, so I've made this little area, right? And the goal is going to be this. First, I'm going to create a new layer really quick under my instance layer, and I'm just going to call this play area instances, play area instance. So this will just, define where the puzzle areas are. And so the idea is going to be this. I'm going to cover up where this little play area is with these blocks like this in any way that I can. And our block will figure out, the rest based on all this, right? Where, first I'm gonna move this real quick. Where you might think what you want to do is kind of make a second type of invisible wall that, lines this, right? So this is an okay idea and this could work, but it would limit your level design a lot because, first of all, it would mean that you couldn't push a block that was on the regular snow into this area, which I don't know if you would ever want to do that, but it means that you couldn't do that. But it also means that you couldn't have an area like this touching up against, say, a scenario like this, where we have an ice patch right next to this little area. We couldn't do something like that because, assuming the ice walls would probably use the same thing, then this wall would either overlap, if you're outlining this one, then it'll either overlap on here, or if you're outlining this, then it'll start overlapping in these areas, you see? And again, that could be solved by making a totally separate object, but again, you wouldn't be able to do things like pushing blocks into these areas and things like that. And plus, this is just a lot nicer and less messy looking, even though you can hide layers. Okay, yeah, so there's this new silly little bug in GameMaker in this new version, I guess, where if you hit Control-Z too many times, it will just crash. So, yeah, just save often. Anyways, I'm going to get rid of that. But anyways, so like I was saying, you can hide this layer and everything, but it's still nice, especially whenever you get to making more complex areas and stuff like that. It's still nice to be able to just have it properly highlighted and be like, oh, okay, this is very clearly the area that we're working with. So anyways, I'm just gonna leave all that there because we're gonna use that. Oh, I got all unorganized, man. There we go. Okay, so going back into my push block. This is super easy to do. I know that was a lot of setup. You guys know me. If you've seen the channel before, I explain things way too much and talk too much. So yeah, I was literally just explaining the benefits here. The way we accomplish this is going to be extremely easy. So, let's see. There we go. Okay, so actually before we go into the step event, let's go into our create event because we're going to want to make a variable for this. And that variable is just going to be called push block area. And we'll set that equal to false in the beginning. So basically this will just be a flag where once we touch, one of these push block areas, we know that we're like in a recessed area and that we shouldn't exit one. So let's go to the step event here. So before we go into our sliding state, we can just figure out what kind of ground that we're on. And it doesn't really actually matter where we do this. Like I said, this is very simple. There's not a lot of like asterisks that go with this, if any. So let's just do it in between the states. We're not actually doing it in the states, just, you know, before we're actually calculating the movement, let's say. So let's add in get ground type, because we're going to also, you know, do the ice stuff. So let's just say if we are place meeting with our X and Y with an object push block area, then our push block area variable is going to be true. Easy enough. And you know, technically you could just say, and if we're not running into one, then push block area equals false. Can't really think of an easy situation where you could get the block out of the push block area. That's not really how, you know, it should work mechanically, unless you have some like more complicated mechanics or something like that. You're like warping the blocks. I don't know. This part isn't really necessary, but you know, you can have it in there in case you have some kind of weird mechanic where you can like get it out of the thing. So anyways, so I'm going to say this is going to be we're in recessed space or something like that. You know, like it's like a little indent that we can't get it back over the little lip, the lip of the little soft snow. But yeah, so we have that information now. And essentially we can just kind of do what we did with our fake wall collision thing here. And we can just sort of add another one of these. So either above or below, does not matter. We can say cancel movement if we're currently in a push block area, but our target coordinates aren't. So if the space we're trying to move in is not occupied, you know, by this object, then we'll stop. So first we'll check if, you know, if push block area is true, you know, so if we are in the indent, then that's the only time we want to check this. So if push block area is true, we're in an indent, and we are not place meeting with a push block area object at our target X and target Y, like this. Oops. Target Y, then we can set our speed to 0, just like we did down there. So yeah, this is basically just saying if we're in an indent, but the place that, you know, we're told to move is not in that indent, then don't actually move there. That's it. That's all it is. So let's test it. What we should be able to do whenever we test this is we should be able to, oh, and if I wanted to, I could, you know, you keep this on or turn it off if you want to. Doesn't matter. I suppose I'll keep it on. What we should be able to do is push this freely however we want outside of this right now. But once we push it in here, now it's technically indented, so I shouldn't be able to push it out, which I can't, but I can push it in here. Can't push it out this way, this way. Oh yeah, look at that. And it fits perfectly in all those grid spaces, and it won't get out. Again, you just have to make sure that, you know, whenever you're doing this object in the room editor, that it is snapping into that 16 by 16 grid properly. But I mean, GameMaker will do that. If this sprite is 16 by 16, GameMaker will make sure that all this is snapped into the right place. You know, just make sure the origin's at the top left. It should be. We didn't change anything about it. So, and then if you hide that and you get like to actually look at it, it's like it looks nice and pretty and like it makes sense. And you're like, oh yeah. Of course I couldn't push it out of that, you know, half an inch of snow. That makes sense. But yeah, so great. And the way that we're going to do the ice stuff is very, very similar. So I'm going to unhide this area and let's make our little ice wall thing. And we're going to do it the same we did the push block area. So I'm going to create a sprite. I'm going to call this S ice ground. Again, this doesn't have to be ice. It could be like an oil slip or mud or something like that. You know, maybe the people who hate ice puzzles, if you just make it like mud, maybe they won't even know, huh? But I'll also show you another cool little thing I like to do with the sprite editor, which is a little bit different, especially because my snow is like a bluish tint. And I think it makes sense to make ice like a bluish tint, right? Now I could make it red or something like that, but I just like the color to match where it kind of makes sense, right? So this is a cool thing to do. So I'm just gonna make, this is a 16 by 16 box still, not messing with that at all. And then I'll add like a fake little like shine looking thing like this, right? So I'm gonna image, I'm gonna auto trim all frames. This is still a 16 by 16 size box, easy peasy. I'm gonna go to my, out into the sprite stuff, origin top left, you know, full collision mask for the sprites, but I'm gonna do the 9 slice thing, which is cool. And if you don't know what 9 slicing is, it's basically just well, let me show you. So if I were to stretch this right now, this is what it, you know, would look like if I stretched it in the image editor, and it would do all this stuff. However, you can change the way this behaves by dragging where you want it to like repeat and stretch. So if I were to drag all these in a single pixel like this, then you can see as I pull it out, the middle part gets bigger, but the inside parts actually don't. They stay a single pixel length. So that looks really clean and nice. And you could even click in the middle here, go down to the 9 slice box, The tile mode is in stretch right now for this middle piece. They're all stretching technically, but you know, they're all in their own little constraints. We can tell this middle piece, you know, not to stretch, we can tell it to actually repeat. So it looks like this, which is pretty cool. And you actually get to see the proper grid spaces and stuff like that. So I think that looks nice in the room editor. So I like to do things like this. So these are the settings that I'm going to use for this. It's the same exact thing. It just looks a little bit nicer. I think having a good looking room editor to you is important. So yeah. And also just make sure that it's showing in this right now, but it won't show up in the room editor unless you actually hit activate 9 slice. So make sure that's checked. Anyways, just thought that was a cool thing I'd throw in there. But so now let's create the object for it. And this is just going to be ice ground like this. I'm going to select the sprite for it. Same thing. And if I went into my room and started placing it down, I could show you that you know, it stays in the 16 by 16 thing perfectly, but it's just got this kind of cool look to it and it keeps an outline. Now this blue is kind of hard to see against this, so I'm going to add in my tiles really quick. If you want to just change the color of it, you can. Anything to make it more legible. Okay, so I added in some ice tiles, and then I just, you know, I properly covered them with my ice thing. And I made the ice thing a little bit bigger because we're about to test that. We already know this works, so I made it a little bit smaller. So yeah, we got our 2 separate areas here, and we lined them up exactly how we did the last time. And so now we're ready to add the ice stuff. And it's pretty much just as simple as the push block area thing. However, we got just a couple things to add to it. So let's go into our push block, go into our create event, and now we want to add on ice. Are we on ice? That's it. Now back into our step event, and we're gonna set it basically the same exact way as we did with this. So we're on ice if place meeting x, y, o ice ground, then on ice equals true. Again, this is basically optional, but you know, otherwise on ice equals false. So we've got our on ice variable to true and false, even though this one doesn't really matter. And now we basically just need to solve 2 different problems. One being we need to have the same type of collision that we have with the push block area type stuff, where we can't push the blocks outside of the ice anymore, and we need it to actually slide, right? So we're gonna need to do this slightly differently than we did with the push block area thing. And it's mostly because whenever we calculate our sliding, like how far we need to go, that will basically solve the problem of needing collisions anyways. And so you see what I mean. So instead of going all the way to the bottom of our sliding state with this, you know, sort of fake collision thing that we have for the push block area, we're actually going to go right after we find our target X and Y, because we're going to be calculating it slightly differently. And I say differently, it's actually not that different. We're going to basically be using the same idea that we are right now. With this target X and Y, we are basically checking a space ahead of us where we're trying to move. And then down here, we're saying, you know, whether or not we should move into that space, you know, our collisions. So here's how we're going to do this. Let's say if on ice, keep adding to the coordinates until edge of ice or wall. Simple enough, right? So first let's check if we're on ice. So if on ice is equal to true, then that's when we want to do this code. Now, because we're going to be calculating our target X and Y very similarly, we are going to want to start over with this one, because what we're going to be doing is we're going to be adding the target distance we want to go, which if you remember, our target X dist and target Y dist is basically adding the coordinates of a full grid space, which is how we're checking one space in front of us. So we're just going to want to keep doing that over and over until we eventually, you know, run into a wall or we run out of ice to slide on. So since for our ice stuff, we're going to be redoing this, we can just say reset our target X and target Y first. And simple enough, to reset them, we would just want to say our target Y now equals our start point X, or sorry, our target X now equals our start point X, and our target Y now equals our start point Y. Okay, cool. And now we're going to search each space ahead to make sure there is ice and there is not a wall. And here's how we're going to do that. We're going to use a while loop. Now, a while loop looks and functions really similarly to an if statement. And that's basically what it is, except what makes it a loop is it'll run that if statement forever until that if statement is no longer true. So we'll see what that means once we type it all up. So we can say while place meeting, we're going to check our target X, and now we're going to start checking ahead the grid spaces. So this is going to be our target X plus our target X distance. And then we're also going to check our target Y plus our target Y distance. And first what we're doing is we're making sure that we're still going to be on the ice if we were to continue forward. So we're going to check for object ice ground. And then we're going to need to add the check for the wall as well. But first, let's just finish this out to look at it. So obviously, you know, ignoring walls right now, if the space ahead of us where we're trying to move does in fact still have some ice, that means we can continue sliding. So now we just need to add these target X and Y distances to our target X and Y coordinates. So target X plus equals target X distance and target Y plus equals target Y distance. So again, like I said, this is pretty similar to an if statement, because, you know, if you said if place meeting in our next coordinate ice, then we can keep moving our target coordinates together. That works really similarly, but what while does is we don't even move past this part of the code until it's not true anymore. So no matter how many spaces there is, again, let's just ignore walls right now. So let's say we're just working with one. No matter how many there are, it's going to check this one ahead and it says, okay, there's still ice here, so I should keep sliding. Okay, there's still ice here. Okay, okay, okay. And that checks for this one. We've run out of ice to slide on. And so now our target coordinates don't move anymore. And this is where we're supposed to end up. So we go from here to here immediately for our target, and then we slide to it. It's just a little bit cleaner than using an if. An if can cause problems, especially if we're messing around with the speeds that the push block actually moves and stuff like that. So, but yeah, just it's a nice way to just, you know, get us all the way to where we're going. And if we were to run the game right now, again, ignoring walls, I could show you that that's what it does. It totally slides and everything's all good. It slides just like how you would expect it to. But if I were to add in another one of these guys, we get some weird results because we're not checking for the walls yet. So first of all, this one would probably just totally ignore that, which is cool. And now I can't push this one to the right at all. Two totally different weird behaviors, but they both make sense. The first one passes through this one because we're not checking for the walls yet in our while loop. And the second one, we can't move this one to the right because, you know, our target coordinates are checking all the way over here. And then because that space is occupied by a wall, our little collision here is actually just stopping it from moving in the first place. So to solve both of those problems, now we just need to add in another check to our while loop. And this is going to be for our walls. So for our ice, we were checking to make sure that there was still ice to slide on. And for our walls, we want to make sure that there are no walls in our way. So if not, place meeting, we're going to do the same exact coordinates. We're checking for the same place. So target X plus target X dist, target Y plus target Y dist. You get the picture. And we are checking for an object wall. So as long as we got ice and we don't got a wall, then we can keep moving our projected position forwards. And we get something a little bit like this. So that moves there. That moves there all the way over. This one doesn't pass through that one. They can both get pushed down. You can't push them into each other. You can't push either of them off of the ice. They both slide. Can't push them off the ice in any direction. They're up against one of these walls. Slide them both like this. And yeah, so that's it. We've really got something cooking now. But yeah, if you're getting weird results and something isn't really working, just go back and check and compare your code, make sure everything's working right, make sure everything matches. So yeah, I mean, hey, as far as I can tell, we're golden. But we don't really actually have anything to do with this stuff yet. Like, this isn't, you know, you can't really make this puzzle by itself. You need things like, I don't know, switches or stuff like that to make it work. So let's move on to that. And before you click off, if you've decided to stop watching at this point, thank you for watching. You should check out my Patreon, haha, and also my game that's coming out at some point. You know, just drop by the description, you know, before you head out. Take a pamphlet with you. Thank you. But to anyone else who wants to see the last couple bit of things, including the reset button, which that one's actually pretty important, and I'm putting that at the end, so you better stay. Haha. Yeah, we need to move on. We need to do that. I need to go to bed soon. So here we go. We have the actual block sliding mechanics working, and so that was the main point of this video, but I don't really like leaving these things ungamified. You know what I mean? We don't really have anything to do with this stuff, so this stuff isn't fully related, but I'm going to show you some really simple and really, really easy ways to make like puzzles work with this, you know. So let's make a button, and here is the button. This is just a really simple sprite. It's an orangey yellow button thing. The 0 image index is it up, and the second one is it down, and the collision mask is just right around where the actual button is. And I have the sprite kind of offset to where it'll sit nicely in a 16 by 16 grid. That doesn't really matter. So anyways, we got our button. Now let's make a button object. So this is our object button, set our button sprite to it. Great. And this is how we're going to do the button. It's going to be super easy. So we're just going to say, is this pressed or not? And I'm just going to call this one state. So our 0 state is the button is not being pressed, and the 1 state is it is being pressed. Go into our step event, And let's say if place meeting X and Y with an object push block, then our state will be 1, which means it's pushed down. And if not, our state will be 0, which means it's not pushed. If we wanted to, we could also add the player to this. So we could say, or the object player. So the player or the block is on top of this, it's being pressed down. Easy. If you're gonna add the player, make sure this is an or and not an and. Otherwise it won't work for you. So if you want to, you can just keep it as push block right now. Just make sure it's or, all right? Or, not and. Oops, there we go. And then just so we can reflect the change, we can just say show the button is pressed, and we can just set our image index to be our state. Perfect. If we were to put this in our room, then should be able to just walk on top of this and it looks like it's pressed down. And the same should work for the boxes. So what are we gonna do with this? Well, silly. First of all, we could like put it here. And so we could need the player to press this with like a one of the boxes, and maybe, you know, while it's pressed down, a door is open, and while it's not pressed down, the door is closed. Just because I hate leaving you high and dry, we're gonna do that super quick. It's gonna be super easy. So we're gonna make a gate that opens and closes based on if this button's being pressed or not. So I'm gonna make my gate sprite, and here it is. Super simple. It just like retracts into the ground. So it's just a really simple gate. I use some of the snow colors on the ground to make it look like, you know, it was actually embedded in the ground. And you'll see that it kind of reflects the button. So when it's off, so the 0 image index is the gate fully closed, and when the button would be pressed downwards, the gate is also down. This is about 32 by 32 in size. Doesn't really matter, but that's hard to see. But you can see my collision mask. I made it match the bottom part here. That's all that's really important. And I just put the origin point at the bottom center of it. So yes, so there's the gate sprite. Feel free to copy it or just make something like it. Just make sure that it's in this correct order with the images. And now let's make our gate object. So this is going to be O gate, set the gate sprite. There we go. And so this is going to be a child of the wall object. You know, we want this to stop the player from getting through. So that's cool. Let's add our create event. And for this, what things do we want it to have? Well, first of all, it's going to reflect our button. So it's going to have a state where, you know, 0 is the gate is up, and 1 is the gate is down and open. And then we want a variable called button object, and we'll set that to no one, which I explained earlier was kind of like how GameMaker says that there is no instance for something. Basically, we're gonna pair that button object with this gate, and then this gate's state is going to copy this button object. So we need that variable. That's cool. And then just for visuals, we can go ahead and set the depth in our create event, and we can just set it to the negative bounding box top. Oops, there we go. Negative bounding box top. So that way the player can walk in front and behind it. So that's cool. We can add our step event, and we can say match the state of the paired button object. There we go. So we can just say if instance exists, because we just want to make sure that it actually does exist. And if we forgot to set it that it doesn't crash the game, or something happens to the button object for some reason, then you know, it doesn't crash the game, then we can say our state equals the button object's dot state, like this. So this will make sure that we're copying that button properly. And we'll do the same thing we did and reflect the state change with our image index equaling our state. So this will just change the visuals right now, but let me show you how to pair it, and you know, you'll kind of see what we're going for here. So I'm going to place my gate object just somewhere right over here. And so to pair it with a button object, we basically just want to highlight our button instance. We can double click it, and here we have its unique instance ID in the room. What we can do is we can just copy this, so Control C, and then we can double click our gate, and we can go into creation code. I've covered creation code a lot before. It's super powerful, super useful for a lot of things. But basically what it is it's just like this specific instance of this gate. We can just add more to the creation code here. So this creation code will run, and then any creation code we give it down here will run after this. So we can override this button object being no one. We can override it and say this button object is going to be that specific instance ID of this button here. So now they're paired to each other. That's all we have to do. That's literally all we had to do. And we can test the gate really quick just to make sure, first of all, that we have the collision right. So that's right. The depth is working. It's working like a wall. All that's good. And cool. The image actually reflects what it's doing. Now, it's still technically a wall. And I can show you by putting this over here. And I will press the button with this, which, you know, good. We're making sure that the button gets pressed by those. But this is still a wall. It's just the visual that's changing. So let me show you one more really cool thing you can do. It's super easy. Now there are lots of different ways to accomplish this, and this way is like a little hacky feeling, to be honest with you. A little bit hacky, but we're basically gonna mess with the mask index, and let me show you something. So let's go into our states here, and we'll say this is the closed state. So if state is equal to 0, we're in our gate object, by the way. Sorry if I'm going a little fast now that we're kind of out of the woods with, you know, the other stuff, but anyways, I'm just excited. So if our state is closed, then we can make sure that our mask index matches our sprite index, right? We want it to be the gate. We want it to have this little collision box on the bottom here match up with it. But if we're open, so if our state is equal to 1, then we kind of don't even want a mask index, right? Like, we just don't want to run into this anymore. It's completely gone. Now, you'd think that maybe you could say like mask index equals no one, or mask index equals like -1, or, you know, false or something like that. It doesn't technically work. If you set mask index to anything that's like, I think below 0 or something like that, it just defaults back to being the same sprite index, is my understanding of it. So you can be a little tricky. You can be a little trickster. You can go over here and create a new sprite. So there we go. But you see GameMaker for 1,000 years and don't know where sprite is. I'm gonna call this S no collision. Oh, you're seeing what we're maybe doing here. So first, I'm just gonna resize this to be resize my image to be really small. It doesn't need to be big at all. I'm gonna say maybe like 4 by 4 pixels. I wouldn't set it to 1 by 1 because I feel like in the past, and to be honest with you, this has probably been fixed with GameMaker for, you know, years now, but I feel like a few years ago, having sprites that were single pixel tall and wide caused problems for me for some reason. So I'm just gonna set it to like 4 by 4. That's a reasonably small sprite. So don't need any other image indexes. You go open your collision mask thing, and basically what you want to do is you just want to set it to be precise. What a precise collision does, I can show it to you really quick. So if I draw like a little plus right here, and let's see, hold on. I draw the image here. So this is a square collision mask, but if I hit, oh, here we go. If I hit precise on it, basically what it's doing is it's just filling in these pixels, the colored in pixels. So if you have it set to precise, and there's just nothing here, then it's basically just having no collision mask. So it's just a really easy way to just turn off a collision mask without having to worry about like making alternate image indexes for each sprite that have nothing there, or you know, setting up a system where the gate isn't a wall, but it creates a wall object if the state is closed and it destroys the wall object. Honestly, I just like doing this, and it works perfectly. Not gonna lie to you, it works perfectly. I've used it in everything I've ever done, to be honest with you. So if I open that right now, look at that. I can just walk right through here, nothing's stopping me. And if I take it off, look at that. See, perfect. So you have a perfectly functioning opening and closing gate. So if your level happened to look something like this, where you maybe walked in from this area and then you can't get through here because they're all walls, then you'd have to solve your little puzzle, and you'd have to go like, whoa, maybe something like this. I probably should not have planned for myself to actually solve the puzzle because that just takes too long. But it's fun, man, because you know what? Because it's a game now. Look at that. And now I can move on to the next room. Look at that. That was a puzzle. I solved it, and now I progress through my adventure and my journey as a person and a game player. Okay, so I think that's pretty cool. And with that being said, we only have one more thing to talk about, and that is puzzle resetting. Because, like I said, say for some reason, I mean, with these mechanics here, there's a good chance that you'll never be able to get the player to get totally stuck. But for example, if maybe the block is out in the open for some reason, I now cannot get this block. I cannot get it off of this wall. I can't get behind it, so I can't push it down. I didn't add any pull mechanics because, again, that would be a totally separate thing to add and much more difficult. So that's when we need the reset button. And so let's do that real quick. I'm gonna add in my reset button sprite. Got it right here. Made it looks same exact thing, except I just put reset on it. It's a big ugly red button. So do the same thing you did with the other button. Now I'm going to create my O button reset, pair it with the correct sprite. Same thing, we're gonna have the state variable, but that's really all we need for this one. Gonna add a step event, and we'll do the state switching the same way. So if place meeting, we'll say X and Y with our object player. We don't really need to include the push blocks with this one, but you know, that could be like an interesting thing, like, you know, accidentally resetting a puzzle in the middle of it. So all you'd have to do is just, you know, say or the push block. So we're doing this the same exact way, and we will say if our state is equal to 1, then we can just go into all of our object push blocks. So with any instance of object push block, we will just set our X back to our X start and our Y back to our Y start. And that will just reset their positions to wherever they were in the room editor. So yeah, and then I added my image index equals the state just so you can see that it's being pressed. Added a couple comments, but that's all it does. So if I were to say, put this reset button down here, and this one doesn't have to be grid locked. It really doesn't matter where it is. So I can go up here, test this again, make sure all this is working. It is, but now maybe I don't want it to be stuck in here anymore. And maybe I didn't want to push this one over here. If I hit the reset button, they're right back to where they started. Easy peasy lemon squeezy, everyone. Hey, thank you so much for watching. Nice job getting to the end. I'm clapping. Seriously, nice job. This was a longer video than I was expecting it to be, so thank you for sticking it out all the way through. If this video helped you out at all, feel free to subscribe, like the video, send me a nice little comment. Helps me out a bunch. And definitely check out the Patreon. Got a few different tiers, so you can get your name on the screen here. Also get your name in the shout-outs, which I do at the end of all these major videos. You can get the videos early. You get the project file with all the assets and stuff in it if you need something a little bit more almost tactile to go along with your learning experience. All that kind of stuff. And yeah, so check that out. And definitely keep following me for news on my game called Starcrossed Arcade Special. It should be coming out soon. I've said that for probably basically decades now, but it's really shaping up to be something cool, I think. So if you want to play it, then the only time you'll probably ever hear about it again is on my channel. So feel free to stick around. You can also wishlist it on Steam. That's in the description too, so that helps me out. But anyways, just definitely thank you for watching. Really appreciate it. Hope this helps you out a lot. Hope this helps make your game a little bit more interesting, and maybe you've learned a couple other things from it. So yeah, and so now I gotta shout out my star gamers, who I want to give a massive thanks for supporting me and motivating me. So yeah, special thanks to Nixie Yannick, Null, Joseph Sandlin, Midnight, Aogio, Captain Ludwig, Christian Donovan, Nick 8pod, Jamie Wary, Ty RV, Juan Zhang, Andrei Bogarov, etc. Lee, Alaya Garinga, Ziamar Rubalkava, Jazzy, Howick, Philip Richmond, Elijah P, Myru, Michelle Chicotti, Matt Murchison, Daniel GG, and Arashdeep Sroya. Boy, I hope I got a lot of those somewhat close. You guys are all the best. I super appreciate you. I also appreciate everyone else who helps out on the Patreon, and you for watching the video. Thank you so much. Have a good day. Au revoir.